Hi, my name is Arpita, and today we are going to learn about a very important theorem of triangle, that is basic proportionality theorem, which is also known as Thales theorem, because it was introduced by the famous Greek mathematician Thales. Okay, before going to the proof part of basic BPT theorem, let's talk about what this theorem says. So this theorem says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, then the other two sides are divided in the same ratio. What does it mean? Yeah, so let's suppose this is our triangle ABC and we are drawing one line which is parallel to one side of a triangle. Okay, so if this triangle is ABC, so this parallel line is PQ. Okay, so it means if this PQ is drawn parallel to BC, then EP by PB equals to AQ by QC. This is what we need to prove over here. This is the basic proportionality theorem. Okay, so before going to the proof part, before moving forward, we need to make some construction over here. So first of all, what we need to do, we will join P and C and Q and B, and we have to make two perpendiculars, that is QN perpendicular to AP and PM perpendicular to AQ. Okay, yeah, so let's take two triangle, that is this red and the green triangle, as you can see in the figure. So APQ and PBQ. Okay, so in both the triangles the height would be, we'll consider this height QN is the perpendicular distance, because height would be a perpendicular distance, right? So let's take the area. As we know, the area of the triangle is half times base times height. So the area of triangle APQ, it would be half times the base would be PQ and the height would be QN. Okay, yeah, and the area of the triangle BPQ, the base would be PB, right, and the height is same, that is QN. Okay, yes, so now the area of triangle, taking the ratio of both the areas, that is area of triangle APQ and BPQ, as you can see the heights are same. Okay, so when we are just writing it down, PQ QN, so this half and the height would be cancel out, right? This is not PQ, this is BP. Okay, yeah, this is BP and this is QN. So this and this would be cancel out, the half and half. Okay, so the ratio would be PQ and BP. Now again we will take to another triangle, as you can see in the next figure, APQ and the PQC. Okay, so the area of PQC would be, the base is QC and the height is PM this time, this one. Okay, PM is the height, right? And in this case the area of APQ would be, will take the height PM this time, because the area of the triangle in APQ triangle, both QN and PM is the height, but this time we'll consider the PM as the height. Okay, so half PQ times PM. Okay, this is our third part, fourth, and this is the fifth. Okay, again taking the ratio of both the areas, so area of PQC and the area of APQ. Okay, so half and a half would be cancelled out and the PM and PM would be cancelled out, so we are left with this QC and PQ. Okay, can you observe one similarity in both the cases? right? We have taken two cases, and first we have taken the triangle APQ and the BPQ, and in this next case we have taken APQ and the PQC. Okay, so just look at this red triangle, that is APQ. Both the triangle, this is same. Okay, all right. So we have to consider this BPQ and PQC for moving forward, right? So now let's talk about these two triangles. So look at this BPQ and PQC. We have read about another theorem, that is whenever two triangles are on the same base. Look at this. Both the triangle BPQ and PQC are on the same base PQ, and they are between the parallel line PQ and BC. So since PQ parallel to BC and they are on the same common base, that is PQ, so the area of BPQ would be equal to the area of PQC. Okay, so can we say that the ratio APQ by BPQ would be equal to area of APQ by area of PQC? No, just write in a way, area of APQ by area of PQC would be equal to PQ by QC. Okay, because in both the cases we'll take APQ in the numerator, right? So this is our second part. So if the LHS portion is same, okay, that is APQ by PQC and APQ by BPQ, the LHS portion is same, so definitely this PQ by BP and this PQ by QC, this would also be same. So this is what we have to prove over here. Okay, so from 7th and 4th part we can conclude that AP by PB is equal to AQ by QC. Okay, it means when if a line is drawn parallel to one side of a triangle, that is a PQ is the line to one side of a triangle to intersect two side in two distinct point P and Q, it will divide the two sides in the same ratios. Okay, so this is what the basic proportionality theorem is. I hope you understood this. Yeah, and in our daily life as well, we have like lots of example, lots of application of this BPT theorem, especially in our construction work. If we are constructing something, no, BPT theorem will definitely work out in finding the missing sides. So thank you so much. This is it for today. Thanks.